So in today's class, let us begin the first module. So the first module is on Lebesgue measure. So in module 1, we will be introducing what is called a Lebesgue measure, and we will look at what are measurable sets and non-measurable sets. And now let us first begin with what do we mean by length of an interval. So measure is actually a generalization of the length of an interval. So first let us look at what do we mean by the length of an interval. Let us consider an interval. So let me take a closed interval AB on the real line. Now an interval can be measured using its length. So as usual, length is defined as the difference of endpoints of the interval. So here we will take the difference of endpoints. So if you have closed interval AB, so the length of the closed interval AB will be given by B minus A. Now we can have intervals to be having finite length or infinite length. Then നമ്മുടെ intervals are bounded intervals ആയിരിക്കും. So here this is a case of a bounded interval. So in general you can have an interval of this form. So suppose you can have an interval, so closed A, and on the right side you have infinity. So in that case the length of this interval A to infinity will be infinity. So if you have finite interval, that means if both the endpoints are finite numbers, so in that case the length will be finite. And if you have infinite intervals, so in that case the length will be infinity, and such an interval is said to be an infinite interval. So in general, the length of an interval is defined as the difference of endpoints of the interval. Now the length is an example of a set function. So you can see that given any interval, closed interval AB, so നമ്മൾ intervals എടുക്കുമ്പോൾ so it can be closed interval or open interval. ഇനി നമുക്ക് open interval ആണെങ്കിൽ length of open interval is again equal to B minus A. That's how we define the length. Now the length is defined on any set of real numbers. So for any set of real numbers you can find out the length for interval bounded ആണെങ്കിൽ, so you will get a finite value. So if the interval is unbounded, the length will be an infinite value. So length is defined or if you take length to be a function, so its domain will be all the subsets of real numbers, and അതിന്റെ rangeൽ വരുന്ന values എന്ന് പറയുന്നത് that will be the set of positive real numbers ആയിരിക്കും വരിക. So length will be greater than or equal to 0. So therefore length is an example of a set function. So that's a set function, and you can see that it's a set function which is defined on the extended real numbers. So in extended real numbers, that means infinity is included. So as we have seen, the length can be infinite also. So that's a set function which associates an extended real number to some collection of sets. So length is a function that associates an extended real number to each interval on the real line. Now again let me take I to be the interval. So let me take the interval, closed interval AB, and let me define the set I plus x to be the set A plus x, B plus x. So what I have done here is I have translated the entire set by value x. So each point is translated by a distance x. Now if you look at the length of I, so you can see that length of I is B minus A, അതുപോലെ length of when you take I plus x, so that will be b plus x minus a plus x, which is again equal to b minus a. So length of the interval I will be equal to length of the interval I plus x. So here I have made a translation of the set I by distance x. So you can see that length is translation invariant. Okay. So length does not change under the translation. So if you have a set AB and it is translated by unit x, so in that case the length remains the same. Now again let us look one more property of the length. Now let me take some open set O. Now, as you have seen in one of the previous theorems, so when you are given an open set that can be represented as union of open intervals. So it can be represented by countable union of disjoint open intervals. So let O be contained in union say 1 to infinity in. Now if I want to measure the length of an open set O, that will be equal to so that will be length of union 1 to infinity I n. So that is summation length of each I n. So if O can be expressed as a union of disjoint open sets, so in that case the length of an open set can be defined in this form. So other than the common intervals you have, നമ്മൾ closed interval AB type intervals ആണ് കണ്ടത് ആദ്യം. അപ്പോൾ in general when you have an open interval or complicated intervals, so you can look at the concept of length in this form also. So if നമ്മുടെ O എന്ന് പറയുന്ന സെറ്റ് യൂണിയൻ I equal to 1 to infinity I n ആണെങ്കിൽ, so length of O can be expressed in terms of the length of these intervals I n. So when you have more complicated sets, the length can be, the notion of length is extended to what is called the measure of the set. So നമ്മൾ ഈ കണ്ട പോലെ ലെങ്ത് നമ്മൾ കണ്ടു ട്രാൻസ്ലേഷൻ ഇൻവേരിയന്റ് ആണ്. അതുപോലെ when you take length of, if you have disjoint intervals I n, then length of union I n will be union of summation of length of I n. So we will define measure to be a set function such that these type of properties hold. So measure can be defined as a function which is defined on the set of all real numbers, and measure of this union of the sets will be equal to summation of the individual measure of the sets, and measure is translation invariant. So we'll generalize the notion of length to intervals, so to sets other than intervals, and this general set function which you are going to define will be called the measure. So let us look at the notion of extension of the length. ഇനി നമ്മൾ ഓപ്പൺ സെറ്റ്സിന്റെ കേസിൽ കണ്ടു, ഓപ്പൺ ആണെങ്കിൽ so you can write it as union of disjoint open intervals. Then you can look for what is the length of an open interval എന്ന് പറയുന്ന length of union I n ആയിരിക്കും. So this is the case for open sets. Now there can be complicated sets as well. So there can be open sets, closed sets, they can be sets which does not have neither of the behaviors. So for any type of sets you have, let us look for what is the length, and in general what is a measure of such a set. Any arbitrary set is given to you, so let us look at how to measure a set. So here we will be having a set function and we will be defining this new set function which we call as m. So m എന്ന് പറയുന്നതാണ് നമ്മുടെ measure. Now measure will assign a non-negative extended real number to each set of real each subset of real numbers. So നമ്മള് script m എന്ന് പറയുന്നത് നമ്മൾ define ചെയ്യുന്ന subsets of real numbers ആയിട്ട് define ചെയ്യും. That can be any type of sets. It need not be necessarily open, closed അല്ലെങ്കിൽ രണ്ടും ആവണം നിർബന്ധമൊന്നുമില്ല. So script m denotes any arbitrary set of any arbitrary subset of real numbers. So on the script m we are going to define set function m that assigns to each set a non-negative extended real number, which we are going to call as the measure of the set E. So if you have E to be a subset of real numbers, so we will look at what is called measure of E. So measure will be a non-negative extended real number. ഇനി നമ്മൾ ലെങ്ത്തിന്റെ കേസിൽ കണ്ട പോലെ ലെങ്ത് ട്രാൻസ്ലേഷൻ ഇൻവേരിയന്റ് ആണ്. നമ്മൾ ഡിസ്ജോയിന്റ് ആണെങ്കിൽ ലെങ്ത് ഓഫ് യൂണിയൻ വിൽ ബി സം ഓഫ് ദി ലെങ്ത്. ഇങ്ങനെ കുറെ പ്രോപ്പർട്ടീസ് ഉണ്ട്. സോ ഐഡിയലി വെൻ യു ഗോയിങ് ടു ടോക്ക് അബൌട്ട് മെഷർ, സോ നമുക്ക് മെഷർ അതുപോലത്തെ സർട്ടൺ പ്രോപ്പർട്ടീസ് സാറ്റിസ്ഫൈ ചെയ്യണം. സോ മെഷർ ക്യാൻ ബി ഡിഫൈൻഡ് ഇൻ ഡിഫറെന്റ് വേസ്. അപ്പൊ എനിക്കൊരു കാര്യം ഞാൻ ഡിഫൈൻ ചെയ്യുന്ന പോലെ നമുക്കൊരു ഇന്റർവെൽ പല രീതിയിൽ മെഷർ ചെയ്യാം. സോ വി വിൽ look at ideally what all conditions a measure should satisfy. So ideally we would like to have a measure to have the following properties. So first ഞാൻ ഏതൊരു സെറ്റ് എടുത്താലും മെഷർ അതിന് ഡിഫൈൻഡ് ആയിരിക്കണം. So m of e, so measure of e is defined for each set e of real numbers. So it must be defined for any subset of real numbers, any subset e of real numbers. So your domain of the set function, that is script m. So script m is the domain where the function small m is defined. So script m will be the power set of R. So this will be the power set of the set of all real numbers. For an interval I, so interval that means you have closed interval a b, അല്ലെങ്കിൽ you can have bounded intervals. ഇത് closed ആവാം, open ആവാം, then one side open വരുന്ന case ആവാം, or you can have infinite intervals. So whenever you have an interval, the measure must be equal to the length of the interval. So ideally that's how I'm going to define my measure. So measure of an interval will be its length. And again if you have the sequence en of disjoint sets where for each an n is defined, so m of en is defined for each en, then if you have a sequence of disjoint sets, then a measure of union en will be equal to summation of measure of each ens. And again the last property it must have is translation invariant. So measure must be translation invariant. So if I have E to be a set, so if I take E plus Y, that is a set where every element in E is translated by unit Y or distance Y, so it will be translated to x plus Y for all x belongs to E. So it must be translation invariant. So measure of E plus Y must be equal to measure of E. So these are the ideal properties that we would like to have for a measure. So it must be defined for all any subset of real numbers. Measure of an interval must be its length. Measure of union of disjoint sets must be sum of the measures, and measure must be translation invariant. Now when you see when you go to the definition of defining the measure, measure construct, unfortunately we can see that all the conditions cannot hold. So some one or more of the conditions must be weakened so that we define the measure. So measure such that it satisfies the last three properties. So we'll be weakening the first condition. So in the next lecture we will look at definition for the measure.